Good morning. Welcome to the Surface Safety Symposium, Airport Operators and Vehicle Drivers. I am Burke Rhodes, Division Manager of Airport Safety and Operations for the Office of Airports at FAA, and will be moderating today along with others from my team. To get things started today, we want to first show a great video on the importance of airfield drivers' situational awareness.
Situational awareness is a key safety factor for all airfield drivers. Every time we glance at the airfield, we see vehicles move about quickly, almost transparent to the operation. The only way these vehicles can do this safely is maintaining situational awareness. Today we met up with Sarasota International Airport vehicle operator Richard von Itterstein.
Most important thing about being an airfield driver is safety and situational awareness. So always keep your head on a swivel, always know what's going on around you. That just helps you be really aware of anything that could come up, any reason to stop, and always giving way to every aircraft that's moving.
Rules, regulations, and procedures. They are there for a reason.
If you don't keep your head on a swivel and if you don't follow all the safety regulations in place, you can really put people's lives at risk, put aircraft in danger, and put yourself in danger. Just of being in the way of an aircraft or having an unsafe practice. So like right now, I can tell that an aircraft's coming in because we have wing walkers and an aircraft's coming around the corner. So we stop short and give plenty of room for the aircraft to move into the gate. If we got too close to the gate, the aircraft could have to stop, make an emergency stop. We could impact safety of the traveling public, or we could actually get in the way and cause an accident.
Richard may be inside the vehicle, but his head is always 100% outside the vehicle.
This runway has a low approach, so we usually stop. We will stop and look for aircraft to make sure there's no incoming aircraft for our runway 4 approach. It's good practice to always scan and be aware of all the aircraft around.
It's a complicated process, and the margin for error is 0. So you may ask, what drives this driver?
So for me, I just love airports. So I want to do everything that I can to make that airport function properly. Having a passion for situational awareness, a passion for airports, a passion for safety, and just making sure that I am following all the rules and staying in the designated aircraft and, the designated vehicle roadways.
A passion for safety. That needs to be the focus in everything you do. So what is the one thing that could derail your safety focus?
One thing that we see nowadays that is a careless mishap for new employees and old alike is the use of cell phones in vehicles and on the ramp. Every once in a while I will see people standing on the ramp with a cell phone out, and I have to go let them know, hey, we don't use cell phones on the ramp because then you don't have good situational awareness. And it's a year 2021, this is what happens. Some of the common things we see are people not paying attention, people waving, looking around, and not paying attention to wing walkers when an aircraft's coming in. When an aircraft's coming in, there are certain telltale signs. Wing walkers in place, jet bridge ready, aircraft movement, lights are on, and if you aren't paying attention, it's very easy to go too far or to get in the way.
Richard has seen what happens when situational awareness is not the first thing on an airfield driver's mind.
A common mistake we see is a vehicle will drive between wingtips. That is not allowed. It's always best to drive around the aircraft, and I have actually seen a vehicle crash into a wing and almost cut the top of the vehicle off. So it had a wingtip smash right into the windshield because they weren't paying attention. They tried to drive in between aircraft.
Review your facility's airfield driver operations and always maintain situational awareness. Even though they are always on the ground, airfield drivers are still part of the NAS. Working together with pilots, controllers, and ground crew, we can ensure our national airspace system remains the safest in the world.
The video we just presented to kick off today's event sets the stage and reminds us that situational awareness is a key safety factor for all airfield drivers. Working together with pilots, controllers, and ground crews, we can ensure our national airspace system remains the safest in the world. We are excited to bring together airports, airport stakeholders, and the FAA to discuss surface safety. I would first like to introduce Shanetta Griffin, Associate Administrator for Airports, to share a few important remarks regarding today's event.
Welcome, aviation professionals. Thank you for being here with us today. I am pleased to welcome you to part 2 of our Surface Safety Symposium, which is focusing on vehicle drivers and other airport surface operators. This virtual symposium will include panel discussions and presentations on surface safety and operational concerns associated with vehicle drivers and other operators. In this virtual conference room, we recognize familiar names across our industry, including airport operators, federal government or state agencies, and several important aviation organizations and associations that work tirelessly to support important safety events such as this. We understand the importance of airport safety, especially as it relates to vehicle drivers, and you are a critical part in making this happen. In this symposium, we will discuss and share pertinent safety-related topics including airport safety and standards, current mitigations, technology, surface event trends, operational safety on airports during construction, surface safety hot topics, and an update on the efforts with NOTAM modernization. We all share remarkable passion and bond for aviation and airport safety. We believe our collaboration in this important effort today will further enhance the great things we collectively do to enhance safety at airports across the country. Today will be informative, and I am confident you will leave this symposium with new ideas and revived enthusiasm to bolster your efforts in support of keeping our airports, vehicle drivers, and surface operators as safe as possible. Thank you for your participation and welcome to the symposium.
Thank you, Shanetta. Now I have the pleasure of introducing Tim Morrell, the Acting Chief Operating Officer for our Air Traffic Organization, to tell you a little bit more about why this symposium is important and welcome our participants.
Thanks, Burke, and hi, everyone from the Air Traffic Organization. First of all, I want to extend our appreciation for the work you do on the airports every day. Obviously, we are the ones that operate, maintain, and modernize our air traffic control facilities around the country. Most recognizable, of course, are the control towers. So we're glad that you're here participating today. One of the things that I think you all recognize about aviation is that we consider safety to be job one, and we focus on that. And within the Air Traffic Organization, we depend upon our safety management system, or our SMS, to help us guide any changes, the things that we do every day, the procedures that we put in place. And the fundamental principle of our SMS is continuous improvement. Now, we've had a few surface safety meetings with other parts of industry to include commercial aviation, general aviation. And here's the fun part, where we get to engage you and hear directly from you, the airport operators and vehicle drivers on airport surfaces. You see what's happening out there every day. You're a part of it, whether it's directly involving your operation or something you may observe elsewhere on the airport surface. So you literally are the eyes that right there on the front line, seeing what's happening, of course, in concert with our folks in the tower, and you get to see it a lot more up closer than our folks can. So really looking forward to the results at the end of this tomorrow. I think tomorrow is when we hear directly from all of you. We have a lot of information to share today, but again, this is about you. We want to share information geared towards you all, and then take back your perspective as we work through this entire system and really try to continuously improve our airport surface safety. So thanks for participating. Look forward to your input, and I'll see you out there. Have a great day and enjoy it all. Back to you, Burke. Thanks.
Excellent. Thank you, Tim. Echoing both Shanetta and Tim's remarks, we are happy you have joined us. As Shanetta mentioned, today is an opportunity to share a series of discussion topics chosen to promote surface safety discussions. We reached out to industry experts to provide their perspectives to several important topics. Before we introduce our first presenter, I would like to remind everybody participating that you are welcome to ask questions throughout the event by the question and answer section within Zoom. Due to the size of the number of attendees, we likely will not get to all questions, but we certainly will be reviewing all questions asked for future targeted outreach. Now I would like to introduce Kelvin Ampofo, who is the Airport Operations Branch Manager within the Office of Airports at FAA, to introduce the next presenter.
Thank you, Burke. Good morning, everyone. I'd like to introduce the first presentation and presenter. The topic, Airport Safety and Standards Program, Current Mitigations and Technology. Steve Debin is the National Resource Expert for Airport Design in the FAA's Office of Airports and is the National Program Manager of the FAA's Safety Award-winning Runway Incursion Mitigation Program. Steve is a civil engineer with a professional engineer's license in the Commonwealth of Virginia and holds a civil engineering degree from Michigan State. With the FAA, Steve works on a myriad of programs, but his focus is on airport geometry, international aerodrome design, aircraft and airport compatibility, runway de-icing, airport integration, wrong surface event mitigation and research, and more recently, the update to Advisory Circular 150-5300-13 Airport Design. We appreciate Steve taking the time to be with us today and look forward to his presentation. Steve, the floor is yours.
Okay, my name is Steve Devin. I am as Kelvin, I really appreciate the kind introduction. I appreciate also everybody attending this morning. It seems like we've got a pretty good crowd attending. So I'm going to get right into it. First, I want to kind of go through a little bit of a summary of how we are organized within the Office of Airports Safety and Standards Division. We're divided in primarily two divisions, AS 100, which is the airport engineering, focus on the policies of safety and standards, and I'll get into that in a minute. I am actually in AS 110 over here. We focus on the design and construction. And as you guys have already met Burke and Kelvin over here in the AS 300, they primarily focus on wildlife or the airport safety inspections and airport operations. So this is a little bit more specific as to how we're broken down. I focus, my job is mostly on design and construction. We also do some safety and standards as well. There's another group within AS 100 that focuses on airspace, airport and airport data, 5010. If any of you have been to the airport data and information platform, ADIP, that is run by AS 100. AS 300, who is going to be doing the bulk of the production of, at least from the Office of Airports, material today, and they focus on the safety inspections, airport operations, including even more recently the drones. Part 139 inspections, wildlife hazard mitigation, and airport rescue and firefighting. So today, I really want to focus on how we in the design and construction branch really try to promote safety on airports, and we do that through our advisory circulars that promote specific types of design and construction guidance. My job is mostly focused on runways, taxiways, and aprons. We also provide guidance on other facilities. There's drainage and grading, things like that. And then another big piece is marking, lighting, and signage. That's a really big piece as far as, especially for you all, on maintaining your situational awareness. I really like that video actually earlier that really hammered home the maintaining the situational awareness. You'll find that is going to be a common theme throughout my slides here. We also, one of the biggest things that most of the AIP money goes to pavement design. So we have a rather robust pavement design and research program. A couple of great pavement engineers, Harold Honey and Jeff Chrislip, lead that group. I believe later we're going to be talking about, not we, but some of the other folks will be talking about construction safety and phasing plans and safety within construction. And obviously we have one of the, I think it might be our largest AC is the construction specs. So all of these form the backbone of how we in the Office of Airports really try to provide a cohesive message on how airports ideally should be run and should be designed. Understanding that we are also stuck with legacy airports, and I'll get into that a little bit later. But every airport's different. Every airport has its challenges when it comes to geometry and safety and operations. And I want to talk a little bit about some of those challenges and how we can perhaps maybe mitigate them. One of the big things from my perspective, and this applies to pilots and vehicle operators, is having channelized taxiing, specifically when you're coming up to a runway. The image on the right is really kind of the ideal of what we want to see at an airport. It's 90-degree entrances to the runway. The taxiways are proper width. That enables the signage and the marking and the lighting to be placed in a standard location, so they're easily seen. And again, this maximizes your runway, your situational awareness. Having a configuration like that also really reduces the chances of having a runway incursion. When you have a standard marking and you have standard vertical signage, it really helps the driver or the pilot understand where they are. And also the signs, particularly the signs, they're a little bit more all weather. You can see them a lot better when it's low light, or it's raining, or it's snowing. Having those not too far away from the center line of a taxiway really is one of the most important things. And this can even sometimes be a challenge when you have smaller aircraft, even if the taxiways are designed to standard. You can sometimes have challenges if you have a small Cessna 172, or even airport vehicles that are smaller and tend to be lower to the ground, may have some challenges with some of these larger the larger taxiways that are designed for your 777s or your 747s. But primarily, I really want to hammer this one home, that having channelized entrances, having proper spacing from the center line of your signage is one of the most important things that you can do to maintain the situational awareness and really help minimize runway incursions. A couple of other design concepts that we talk about in primarily the airport design EC, but also this is touched upon in the marking EC as well. One of the big things that I know this is a challenge in a lot of airports, but having the 3-path concept, that concept provides a situational awareness when a pilot or a driver comes up to an intersection, and they only have 3 choices. They can go left, they can go right, or they can go straight. This allows, I should say, this really minimizes these wide expanses of pavement that really does reduce your situational awareness. It's not necessarily intuitive to see which center line you're supposed to follow, if there is a center line, which leading up to it, if you have more than these 3 choices. The signage leading up to the intersection may be a little confusing, maybe a little misleading, even if the operators doing the best they can to maintain signage. Just having this geometry can be very difficult, and we understand that a lot of the facilities across the country, like I mentioned earlier, have been around a long time, and a lot of it was built more for straight lining to make things a little in what seems more efficient to get aircraft from point A to point B. But a lot of times what that does is that can create confusing intersections. And the challenge from my point of view is to get these unwound across the country as much as we can to try to promote situational awareness for both the pilots and the drivers. Then the next piece of it is one that you may have seen, you may have heard about also, that we're really trying to promote, is to remove direct access to the runway from an apron. The visual here on the right really kind of demonstrates what I'm talking about here is that we really want to have at least 190-degree turn before you get to runway entrance. This promotes a situational awareness for pilots and drivers to understand that they are coming up to a hold line or to a runway, as opposed to going straight from an apron and you may not be aware that you're already upon the hold line, and or may hopefully not have passed it. Having these turns prevents just that. Well, I shouldn't say it prevents, it minimizes the potential of having an aircraft or a vehicle accidentally move past a hold line. As a standard, or as an operator, why do I care? Why do I care about all this? Well, the standard geometry helps create a lot of consistent expectations across the national airspace. If a pilot or a vehicle, this is more for pilots, but that's also an important piece about airport operations is, how the pilots move around the airport. And if they see one entrance and they see another entrance and they're the same, they at a different airport, they understand they understand the expectations, they understand where the hold line is going to be, they understand where the sign is going to be, and it creates less of a confusion between the airport operator, the pilot, and the tower as to what the expectation will be. Proper airport design also promotes efficient movements. And what I mean by efficient movements is that aircraft can make turns, even 90-degree turns at a reasonable speed without having to slow down. And so the proper fillet designs and the proper using the proper radius facilitates that. And again, I'm going to bring this to the forefront again, and this maintains situational awareness. When you have an expectation of what the geometry will be, it gives the pilot a level of comfort and a level of understanding of where they are on an airport. This is why we really focus on maintaining consistent and standard signage, lighting, and marking, so pilots and vehicle drivers always know where they are in the airport. This obviously has some benefits: runway incursion prevention, and if there is an incident, when you have proper spacing and you can mitigate an incident if an aircraft wanders off a taxiway or something. That if there's proper spacing, the incidents are minimized to just the specific aircraft and hopefully just the gear, and they can get right back on the pavement. And this also minimizes your hotspots across the country, across your airport. Not having any of these confusing areas, both at a runway entrance or elsewhere on the airport, that you may want to try to prevent taxiing aircraft, wingtip collisions and things like that. Having standard geometry everywhere helps minimize those hot spots as well. So I've talked a little bit about the problem, and we'll talk a little bit more about the problem, and then I'm going to get into some of the potential solutions to these issues. So, you can have, as I mentioned already a couple of times, you have legacy airfield layouts with, that were, use a lot of straight lining between point A and point B of getting aircraft across an airfield. Oftentimes, creating odd angles and creating more than one decision, more than the three decisions at an intersection, having less than 90-degree entrances to runways, things like that. And the other piece is that there could be geographic constraints. So even if you have you're doing all the proper standard, the proper design and right angles and everything, you may not be able to get the proper spacing. So that can create some odd and challenging marking layouts and lighting. Signage layouts at some of your your runway entrances. So that, it's kind of there's a lot of challenges out there with every different airport, but there's also the good news is there's a lot of solutions, and there's a lot of things that we're currently working on that are either in the system already or coming into the system. And I'm going to talk about all four of those, particularly the first three, as is in the next few slides here. So runway incursion mitigation is a program that was derived from the concept that we call problematic taxiway geometry. So the runway incursion mitigation program is focused on fixing or minimizing or reducing or mitigating runway incursions through the use of proper geometry. And I've mentioned that a couple of times already, how important that is for airports to try to achieve. The foundation of the Runway Incursion Mitigation Program, or RIM, is this concept right here: problematic taxiway geometries. And what these really are taxiway design elements that we have found that have a commonality with, unfortunately, promoting runway incursions. I won't read through all of them, but I will highlight the top few, that these are the ones that are the most common and then create the most runway incursions. You have a short taxi distance from ramp or apron area to a runway. That's related to the direct taxiing access to runways from ramp areas. And that was one of the items I highlighted a couple slides previous. This is something that, if you have such a short distance, there's not a lot of time for pilots to understand where they are on the airfield. And this applies to the vehicle drivers as well. If there's not a lot of time for them to really digest where they are on an airfield before they get to a hold line, that could be an issue. One of the other geometries I mentioned earlier, I'm going to show a couple of examples of that here in a second, is the taxiways intersecting the runway other than a right angle. And what I'm really talking about is not high-speed exits, because those are designed to be exits and really exits only. I'm talking about runway entrances at the end of a runway that aren't at a right angle, or at least very close to a right angle. And that also is related to the next one: wide expanses of taxi pavements along a runway. So if you have a taxiway that's intersecting a runway at other than a right angle, that creates wider pavements to maintain your fillets along to allow the aircraft to access the runway and make turns. The greater the angle, the wider the pavement, unfortunately. And we really try to we were trying to promote this right angle entrances to maintain that situation awareness. And then that also relates to number 10, or PTG 10, the non-standard markings and or signage placement. When you have odd angles, you have multiple taxiways that intersect together, it's very difficult to get standard marking and signage placement on your taxiways, particularly relative to the center line of the taxiway and to the eye of the pilot or the vehicle driver. And then on down the line, but I really wanted to highlight this top few of the ones that we see the most frequently and that contribute to the most runway incursions. Some examples of what I'm talking about: on the upper left there, you have an entrance to a runway that's not at 90 degrees, and you can see how wide that pavement is to facilitate the aircraft to be able to take off on runway 19 there. Similarly, you have a wide expanse of pavement on the upper right, where you have two different entrances coming together onto one, and you have this uniquely and oddly shaped hold line, and that makes it difficult to see the signs at certain angles. The lower left, you have two taxiways against somewhat similarly that join together. Actually, they join together past the hold line, and that can create some confusion as well. And that also, again, you can see that the hold line is a little bit wider than it should be for a standard entrance. And then another example that I didn't really touch on, but was listed in the previous slide, was this idea of two runways that are closely spaced. And then you have hold lines that are very, very close together. In rare cases, but this does happen, where you have the hold lines that are actually reversed, and you haven't cleared one when you have to hold at the other. And that can create confusion as well. So these are a couple of the geometries. I've got a few more on this next slide here. On the left, there's a wide expanse of pavement. You have three taxi lane or entrance taxiways that are entering the runway that do not have any islands, and that does not allow you to place your signs in the proper location. So an aircraft that's entering a taxiway Alpha 1 may only see one sign on the left. Taxiway Alpha 2 does not see any vertical signs at all, and they won't see any lighting at night, because the lighting will be all the way on the right side of taxiway Alpha 3 or the left side of taxiway Alpha 1. This is also an issue for drivers as well, if they approach at any other location other than the near the sides and edges of the pavement. The top middle image shows, again, another example of the entrance taxiway that's not at a right angle, and you can see how wide that pavement gets. You do have somewhat of a channelized entrance at the hold line. But the angle also does another thing. It doesn't allow, and this is particularly depending on how an operator runs their airport, but if a vehicle driver is holding at that hold line, they can't see any aircraft it's very difficult to see the aircraft that are landing, behind them. And this is an issue for pilots as well. So the situational awareness for pilots and drivers at that hold line is minimized because of this, the approach into the angled approach into this, the angled entrance into this runway. Another example of the violation of the three-path concept that I talked about earlier is on the right. This is somewhat common at your much larger airports. Well, I shouldn't say common, but it does happen at these larger airports where you get to more than the three choices when you come up to an intersection, and that creates this wide area of pavement that doesn't necessarily have any vertical signage or lighting. And the one in the bottom center has a couple of issues going on here. You have a high-speed exiting directly into directly to another hold line. That can be a challenge for aircraft that are exiting that runway. The two taxiways meet beyond the hold line. Because of that, you have a wide expanse of pavement, and the markings become very wide and the signs become very far apart, as well as like I said, the taxiways meeting beyond the hold line, that can be confusing unless the direction from the tower is very specific on when they should hold. And again, this can be a challenge for vehicle operators as well. When you're coming up on one of the taxiways and want to enter the runway, you may not see the signs depending on how they're located, but that's a pretty wide area there. So what do we do about this? Well, we've been tracking this across the country for about 7 years now. We started this in June 2015, the Runway Incursion Mitigation Program. And what that does is we take runway incursion data and we geo-reference it to locations across towered airports. And we find a commonality of where they take place, and then make a determination if it's significant enough to pay closer attention to. And we do that by tracking if a specific location has more than one runway incursion in a calendar year. I'm sorry, if it has 3 or more runway incursions in a calendar year, or averages more than 1 runway incursion over the last 10 years. We limit it to the last 10 years because, really that's about as far as reasonably can be assumed that operations are the same, fleet mixes are the same, and it gives you enough history to determine what's really happening at that location. So it's 3 or more, like I said, I'm going to highlight this again, 3 or more runway incursions in a calendar year, or if you average more than 1 runway incursion per year over the last 10 years. And once that is been highlighted, we go through a fairly thorough evaluation and validation process to make sure that we understand what's happening at those locations before they become a RIM location. The first piece of this is the contractor goes through and reviews and assigns the runway incursion based on reports we get from the Runway Safety Office to make sure when they read the reports, they assign a location to them based on the report. And then they highlight, the 3 or more, or average 1 per year. And then once they do that, we go through and I say we, the contractor, myself, and a few others from headquarters. Tom Mize, who you'll meet later, is also part of this group. We thoroughly review the runway incursion reports, make sure that they're related to loss of situational awareness, because that's really a key piece of what RIM is about, is the situational piece of it, because communications errors will happen regardless of what the geometry looks like. And so we try to, we filter out those runway incursions that really aren't related to this loss of situational awareness. If there are communications, it doesn't matter if it's the perfect day, time, weather, perfect geometry, the runway incursion would still happen if it's related to communication. So once we do that, pretty thorough review, then we send it to our local ADOs, a selection of a list of, I think this year was about 24 candidate locations to review. Again, since we can only base it on a Google Earth review, obviously we can't travel to all of these airports to ensure what's going on at the local level. And then the local folks will review them based on, is the geometry still there? It's in theory, it's possible that construction could have happened. Were the runway incursions in themselves valid? And what I mean by that is, where there's something that was happening at the airport that maybe contributed to the runway incursions that otherwise wouldn't have occurred, like an air show or construction, or something else locally that may have changed the way the airport operated on a temporary basis and maybe spiked some runway incursions. And then they also double check and review the runway incursion reports themselves to see if they're the third line of defense about whether these are related to situational awareness, and whether they're located in the proper, whether they were assigned the proper location based on the reports and what they know about what's going on at the local facilities. So once they've done that and we all come to consensus, then those locations are added into the public inventory for RIM that's located at this website that you see at the bottom of the screen. And this is a dynamic list that changes as we mitigate some, and yearly we add these, we include these locations. And I forgot to mention that we go through this validation process once a year. So we just finished about a week ago the validation for the calendar year 21 data for runway incursions, and the new inventory was just posted a few days ago on our website. So hopefully, if you have a tower and you know you might have some runway incursions, you've been in contact with your ADO already and about looking forward to solutions. But you might want to give it a check and then follow up with your local ADO if you have any questions about any of those locations that are put on that on our inventory on the website. So I want to talk a little bit about the successes that RIM has had so far, and give you, first of all, I'll give you a little bit of the state of the program at the moment. Obviously, the runway incursion mitigation program requires the participation of everybody, FAA and all parts of FAA. Airport sponsors are obviously the leaders. They develop the ALPs and they look at how to really, they're the drivers and the leaders of the solutions on their facilities. And then industry, this includes, the consultants and, vendors and, contractors that help, we all have to work together to get this accomplished. The runway incursion information, as I mentioned before, that really determines the priorities of how the airport itself, and then even as our regions and our ADOs determine funding on where is the most important, what are the most important projects from a safety perspective that they should focus on. And again, I'm going to say this one more time. We're trying to promote the standard geometries across the country. The more standard, the more consistent we can be, the safer everybody is, and on an airport level and on a nationwide level. But as you can see here, kind of the state of things is, currently we've reviewed 520. We have 522 towered airports in the system, almost 15,700 runway incursions we've reviewed since the program started. Currently with 85 airports with RIM locations. The problematic taxiway geometry locations, I didn't really get into that too much, but basically you take, the contractor had examined every runway taxiway intersection, and if they had one of those PTGs that I had mentioned on that bar graph earlier, if they have one of those, then it's counted as a PTG. Does not mean it has a safety issue. I want to be clear about that. It just means it wasn't designed exactly to 13A or airport designs advisory circular standards, which of course would be a lot of this. The number of those locations shouldn't be a surprise, just because, as I mentioned, we have such a legacy airport system that, of course, a lot of areas haven't been designed to those standards as far as the layouts go, but we're working on it. Total RIM locations is 131. We had 20 RIM locations validated from the calendar year 21 data. But the good news is we did mitigate 16 in this current fiscal year. So it's mostly a step forward, a little step back, but we're making a little bit of progress. Another good news piece is we have 19 RIM locations that are currently in construction. So hopefully we'll start getting some more mitigated in the future and add to that number of 86 at the bottom of the screen there. But the best news I can say is that all of the run, getting standards, designing, focusing on the runway incursion locations reduces runway incursions by 83% at all the locations that have been mitigated, which is a really big number. It's something that I can't emphasize enough, that proper geometry and solutions at these locations really does make a difference, both from PDs and BPDs. I want to highlight a couple of successes. I won't go too far into these, but Albuquerque had a couple of runways that had specifically wrong runway events, which are runway incursions. If you see in the upper right there, the two runways were coupled together, and it's pretty obvious as to why it could be confusing, is you take off on 8 when you were supposed to take off on 12, or vice versa. So a few years back in 2018, the airport sponsor and FAA and industry got together and decoupled those runways, separated them, with light there. You can't see it, but there's edge lighting around that green area right here. And the wrong runway events have been eliminated since then. This is a very cheap one, a very effective one. Bowman Field in Louisville, there was direct access from the apron to the hold line here. And all they did was just paint a green island here. And to prevent aircraft from, like I mentioned before, going straight from the apron to the hold line. And it's been very effective since then. No runway incursions since 2019. And one more success I'll talk about is this is a little bit more involved, but it had reconfiguration of a taxiway at Miami International. There was a lot of confusion, wide expanse of pavement right here, and they've tightened it up quite a bit and made it easier for aircraft to see where they are in relative to the previous layout. So that's it for RIM. I'm going to move on to some other airport safety features that the Office of Airports is involved with, policy and design and guidance. A big one that I'm sure a lot of you are familiar with are the EMAS systems. They are placed at the ends of runways. If you have a particularly for land constrained airports or other kind of constraints where you cannot attain a full safety area at the ends of your runways. And we have guidance in the Office of Airports that discuss, what EMAS, how to, how much safety area they take up, or how, let me rephrase that, how they can substitute for certain types of safety areas, how they can, what kind of designs you should consider for EMAS and some of the challenges with installing EMAS. But there's primarily two technologies, the bulk of which are these big crushable concrete blocks. You can kind of see those on the lower right there. And then there's a newer technology where it's a bed of foam glass, recycled glass that they almost kind of look like lava rocks. It's a big bed of that. So what the EMAS does is if an aircraft overruns the threshold or overruns the runway, they crush and they slow the aircraft down in a safe and measured way, in which prevents, ideally it prevents the damage to the aircraft and prevents injury, most importantly to the passengers and the crew. And they are installed currently at 121 runway ends. I think 4 or 5 of those, 4 of them are the foam glass and the rest of them are the concrete blocks. And we've had 18 captures so far that has saved almost 420 people between passengers and crews on all those captures at those locations. So EMAS is a very effective way of mitigating reduced runway safety area. And it's something that it's been around for about 22 years. And it's been very effective. We really hope they don't ever have to be used, but when they do, they do quite well. Another piece of airport safety that I want to get into, and this has much more direct references to vehicle drivers, but it can also for pilots. But the runway incursion warning systems. There are systems in several vendors have systems for vehicles that you can place into your I think there might even be some phone ones, but you basically put these systems in there and they give you alarms on when you're approaching a hold line. And those alarms are also based on, I think they're vector based on how fast you're going towards a hold line. And there's all kinds of different systems that give you different types of warnings and sophistication of the systems. These are clearly supplements for airfield visual aids. We still need to have those visual aids as standards. We can get it. But when you do have unique situations where you might have some, geometries that are going to take a long time to fix, this might be a good solution for your airport. We do have an advisory circular for that, 5210-25A, that has the standards and performance requirements for these systems. And you can install these vehicles fairly easily, is my understanding, and you should be able to. They should be a second resort to having good geometry, but they do perform quite nicely. Or one other piece of technology I want to talk about are ADS-B squitters. The squitter equipment is put in. Obviously, ADS-B out has been encouraged for quite some time to be in all aircraft. But aircraft or airport ground vehicles can also get these installed to provide situational awareness with other aircraft, other vehicles, and the tower by having their own ADS-B out. And this is particularly useful if you do not have ASDX at your airfield. And considering there's 30 to 40 ASDX airports, the rest of them, ADS-B out could be a really good alternative to maintain the situational awareness and ensure that aircraft or all your vehicles are being tracked across the airport. We have an AC for that on 5220-26 that discusses the ADS-B out, the performance and the testing requirements, and the standards for the squitters. So that's another big piece for situational awareness and ensuring that aircraft and ground vehicles are operating at another level of safety across the airport. So with that, I am going to wrap it up, and I will entertain some questions.
Well, Steve, let me just say, in this virtual environment, you took a presentation that's difficult for some. You just made it very easy to understand. We want to thank you very much for that overview and demonstrating how implementing standard geometry at airport standards impacts surface safety. Before we move on to the next presenter, and I know everybody's giving you a virtual round of applause, let me just ask you a couple questions if I can. If an airport does not have an air traffic control tower, how does what you described in your presentation apply to them?
So that's a good question, Kelvin. Really what we've found through RIM and the problematic taxiway geometry studies is that even if you're not having runway incursions that are tracked by the tower, we know what geometries contribute to runway incursions and loss of situational awareness. So even if you don't have a tower and you can't track those numbers, it's still reasonable. We can reasonably identify what areas should be looked at more specifically. And I think even the smallest airports that have some odd geometry, some geometry that creates non-standard marking and lighting. That should be looked at. And, just because they don't have a tower doesn't mean there aren't things happening at an airport, particularly if we have these types of geometry challenges.
Outstanding. Now, about those airports that do have the control towers, are there any other forums to discuss surface movement issues or concerns?
Absolutely. And I think a lot of the folks on this call should be or have been involved. It's the runway safety action teams. Those are critical pieces critical forums for all the stakeholders involved at airports to have a voice on what's happening at their airfield and have a voice on how to solve those problems. The towers, the tower managers, the airport district offices, the FBOs, the airport operators, the airlines, if applicable, all should have a say on what's happening at their facility and have a voice on how those problems get solved. And incidentally, Kelvin, I'm glad you brought that up because RSATs are really the first line of defense even for RIM mitigation because if you label an area hotspot, that's the first line of defense in telling a vehicle operator or a pilot that this is an area where they need to pay a little bit more attention to. And those hotspots are recommended from the runway safety action teams. And obviously the solutions that come out of those RSATs or the RSAPs, the runway safety action plans, and those are commitments from everybody to promote, try to solve these safety issues.
Outstanding. Now, as we want to promote discussion with everyone listening today, and I know that some of the processes you described in your presentation can't be easy. What are some of the challenges in implementing airport design standards beyond the physical constraints?
There's a few. The biggest one, obviously, is it can be long-term, planning and recognition of the solutions. Getting some of these locations on the solutions on airport layout plans. If there's potentially some environmental sensitivities, it can take a long time to develop solutions or to implement the solutions on airfields. Which is why sometimes I think there are almost like phase solutions where you put in a solution like you did at Bowman Field, where it's just a fairly simple marking upgrade, but then the long term is to actually change the geometry, and that's a very reasonable incremental gain that you can attain when you have longer term challenges. Some of the other challenges can be is making sure that everybody's coordinated with as you develop the solutions to your particular geometries. The users, the controllers, and FAA in general need to be involved if you're an airport sponsor and you have some solutions, not just from looking at it from a design and standards perspective, but also everybody knows that the funding perspective is a very important piece of this as well.
Absolutely. We certainly appreciate you. It sounds like communication is going to be a theme we hear a lot today, and we appreciate you, Steve. One last, before we end your session, can you tell us if an airport has a question about design standards or geometry, who should they contact?
Definitely reach out to your airport's district office. I know in certain parts of the country, the airport's district office or the ADO is the same as the regional office. I think it's Alaska, Central Region, and New England. But they're the first points of contact. Hopefully, you all have good relationships with your program managers at those offices. And they have if they don't know the answers, they know who to get in touch with to get the answers. And it could be the regional engineer, or it could be me or one of my esteemed colleagues at headquarters that would get involved with some of those solutions. So those would be the ADO is really the first point of contact, but it's very easy for them to engage resources across the country.
Outstanding. Ladies and gentlemen, again, Steve Devon, thank you again, Steve, for taking the time to be here today and share your expertise. We certainly appreciate your presentation. As we move on to our next presentation, we're going to look to hear about surface event trends. At this time, I would like to introduce Giovanni DeParo, the Runway Safety Group Manager, and Tom Mize, a staff certification specialist and runway safety liaison in the airport operations branch at FAA headquarters. So Gio and Tom, take it away. The floor is yours.
So thank you, Kelvin. Appreciate the warm welcome, and thank you, Gio, again. So our audience today includes airports of all sizes, characteristics, and configurations. And the next presentation is intended to paint a broad picture of trends. So Gio and I will provide an overview of surface events in the national airspace system. And then we're going to look at some airport specific, vehicle pedestrian specific information from the last few years. Now we'll conclude with providing some recommendations to promote surface safety discussions. Now you're going to hear a lot of common terms through this presentation, and we want to cover those at the front end. So here's what you need to know. So a surface event is either a runway incursion or surface incident involving a pedestrian, vehicle, or aircraft on the movement area. And movement area is generally referred to runways and taxiways. So what's a runway incursion and surface event? Now, when we say runway incursion, you may hear us say RIs. This is the incorrect presence of an aircraft, vehicle, or person on a protected area of a surface designated for landing and taking off. Easiest way to think about this is it's the runway, someone accessing the runway. In a surface incident, or SI, these are unauthorized or unapproved movements into the movement area. Now, lastly, we're going to talk about different surface events. So these include operational incidents, which are OIs, pilot deviations, which are PDs, vehicle or pedestrian deviations, which are VPDs, and you may see other, which are essentially any of those that can't be attributed to those described above. Now, let me hand it over to Gio to discuss how we collect the data and talk a little bit about some national trends.
Thanks, Tom. So every event in the National Airspace System, when we start collecting data, starts out with a mandatory operations reporting, so MOR. So those are those reports that at those towered facilities that air traffic control supervisor, CIC, puts into our database that gets captured. Additionally, at airports that have surface surveillance, we have something called ARIA, which is Aviation Risk Identification and Assessment, which also captures what could be a runway incursion or a wrong surface event with that airport. So once we get the data, we also work with our partners in Office of Airports and Flight Standards, and this is more to get pilot statements, investigation results before we kind of bucket that data. You're seeing the slides coming up, what we mean by that. So that goes to quality assurance, and quality assurance, so we have three distinct east, central, and west with different parts of the country that look at the data, and they're going to see if there is a loss of standard separation. Was the aircraft across that whole short line into the RSA, not even getting onto that runway, which we also kind of capture as a runway incursions. Once that data is validated, we get the pilot statements to controller statements. We will sit there and send it to our runway incursion action team, and they will rate the event, and we rate them on a scale of an A, B, C, or D. A being the most severe runway incursion, to where D is typically those that don't really have any conflict. No aircraft on final, aircraft taxis out to the runway, holds short point, and they cross the line without any conflict. So that's a little bit of how the data is collected and bucketed with runway safety. So the next slide, you're going to see, essentially, this is our national trend. So we're going to go back to like 2017, and the top yellow line you see is really the runway incursion rate per 1 million operations. And the line beneath that, that blue line, is the total number of operations within the national airspace system within a given year. So we kind of go back to 2019, which was really the last year that we did not have any effects of the pandemic. And we looked at, we had 53,283,854,000 operations. You see that definitely that dip in 2020. Things started coming back in 21. It's a little bit of a mixed bag. And then in 22, we are at or probably going to be exceeding 2019 numbers. So when we look at the total number of operations for 21, we had 47,469,304. This data lacks probably about 60 days behind. So right now we still have a few more months to add. And you can see that we're already at 47,336,102,000 operations, with the runway incursions altogether of 1,676 for FY21, and we're already at 1,562 for FY22. So we're trending a little bit higher than we even were last year. As you look down the slide, you can see the runway incursions per region. So we have different regions in the continental United States, with Alaska, Central, like was talked about earlier. And these are the total number of runway incursions, pilot deviations, OIs, and VPDs per region. So when we kind of go on to the next slide here, we kind of have it broken down to really those A and Bs, the highest risk runway incursions. So the column you really want to focus on, since we're really talking about vehicle pedestrians, is that drab olive green color. And we look at, for FY22 for this year, which started on October 1st of 21, and it ends on September 30th here next week, we have two VPDs that are going to be an A or a B. And the rest of them are broken down, like Tom showed you earlier, as an OI, which is an action or inaction from a controller, pilot deviation, a PD, and then that other. And that other is that data we get, we really can't attribute it to one of the three. We still want to capture that data, but we can't sit there and attribute it to an OI, a pilot deviation, or a vehicle pedestrian deviation. So when we look at FY22 numbers, of all the category A and Bs, we have really two that are centric to a vehicle pedestrian deviation, and they're both category B runway incursions. So kind of the same data displayed a little bit differently for the different years, going back to FY17 and all the way to 22. And you can see that the highest number you see for runway incursions are those pilot deviations. So FY21, we ended up with 1,135. And this year, with really about 2 more months of data to kind of bucket into these different categories, we're at 994. The vehicle pedestrian deviations, once again, you're looking at 285 last year and 268 this year, with more to add. If we go back to 2019, which is really the last year that doesn't have any effects of the pandemic, we're looking at 295 vehicle pedestrian deviations. All right, so Tom, I'll hand this back off to you.
Thanks, Gio. So a few reminders before I get talking a little bit more about general VPD trends. So I want to remind everyone we're talking about fiscal year data here, which spans between October to September. Now, our fiscal year 22 data isn't complete, as Gio just mentioned. And Gio explained how we obtained the data. Now, the data is important because it does show us how trends are tracking. Now, we obtain this data from controlled facilities, but this data can apply to non-controlled facilities. So we'd heard earlier today from Shanetta and Tim that this trend data really can only tell us so much. And our data and trend analysis is limited to the data we collect. On a daily basis, you may see trends and surface safety issues that simply our data can't uncover. Your perspective at each individual airport is important to identifying surface safety issues, and really one of the reasons why we're partnering with each other today to have these discussions. Now, I'm going to take the next few minutes to sort of unpack the VPD data, beginning since fiscal year 18. That starts in October of 2017. Now, it's important to note that COVID and our fiscal year 22 data is really not representative of a consistent trend track. All of our surface activity decreased, as Gio previously mentioned. Now, a clearer representation of how we're doing will be accompanied by looking at the fiscal year 21 data, along with the 22 data, and then looking forward and comparing it to the fiscal years before 20. Now, I plan on describing vehicle pedestrian runway incursion and surface incident trends only. We're going to look to see how fiscal year 22 is looking, and then we're going to wrap up with Gio again on some recommendations. Now, what you're looking at the slide here is essentially all the counts since fiscal year 18 of VPDs, RIs, and SIs. Let's unpack that just a little bit further. Now, if we broadly take a look at VPD runway incursion data since October of 2017 or the start of fiscal year 18, we can see that runway incursions peaked in our data set during fiscal year 18. Now, between fiscal year 18 and 19, there was a reduction, but unfortunately we ran into fiscal year 20 to see if the downward trend would continue. Now, if we look past fiscal year 20, we can see fiscal year 21 runway incursion events continue to be lower than fiscal year 18 and 19. But our runway incursion events in fiscal year 20 are approaching our fiscal year 21 numbers. Again, I'll remind you later, we're going to actually look to see how fiscal year 22 is tracking based on some data sets. Now, shifting over to surface incidents, so SIs, beginning in fiscal year 18 and fiscal year 19, there was actually a significant jump in SIs. Now, if we fast forward to fiscal year 21, we do see a decrease, but we also note that our fiscal year 21 numbers have already matched our fiscal year 21 numbers. And we expect our SI counts in fiscal year 22 to exceed our counts in fiscal year 21. So for the next part of this discussion, it's important to really understand how runway incursions and surface incidents are tracking in fiscal year 22 as we think about and discuss initiatives and mitigations to address trends. So in order to do this, I had to figure out a way to do apples to apples. And what I ended up doing was looking at the same months. So we're looking at October through August within the fiscal years. What this does is it actually utilizes our partial data sets that we mentioned previously in fiscal year 22. This will allow us to see how fiscal year 22 is tracking. Now, by looking at these snapshots, we really reasonably can make some predictions if runway incursions and surface incident numbers in fiscal year 22 may be trending at or higher than previous years. So keep that in mind as we look at the next slides. Now, again, we're going to start looking at runway incursion data filtered across those dates, October to August for fiscal year 22 compared to the rest of the fiscal years. So here's what we know. In fiscal year 22, we see that we've actually exceeded our fiscal 21 data for runway incursions, and we're trending to match our fiscal year 19 data. So as a reminder, looking back at one of the previous slides that showed all the total, our VPD events in fiscal year 19 were the second highest across our event data history. And these were actually about 10 events higher than our counts we saw in fiscal year 21. So for surface events now, again, filtered across the data, in fiscal year 22, we are trending higher than all previous fiscal years. So in fact, you know how we showed the fiscal year totals really have already matched our previous fiscal years. So it appears that our surface event counts are actually trending closer based on the filtered time frame to those numbers that we saw in fiscal year 19, which were actually the highest that we've seen within our complete data set. So we have some other information that we can talk about. The FAA broadly collects data to give us a sense of who is operating on and what is occurring during each runway incursion and surface event. Now for this presentation, I queried this information for both RIs and SIs. We're going to look at RIs first, and I sorted this by the top 5 events, which are actually shown. Now, these events range from unauthorized privately owned vehicles entering a runway to authorized vehicles or personnel entering a runway. Now, within the top 5, a trend is emerging, indicating a breakdown in communication and situational awareness from surface operators. It's important to note as we look at this again that our data sets are complete, but we're using what we can to make our best guess through August of 2022. So at this point in time, there are 3 of the top 5 events which have exceeded the previous year, and those are shown in red. Now, let me quickly, again, zoom into some graphics and we can take a look a little bit closer at these top 5s. So a little bit of good news. So we have the unauthorized privately owned vehicles or pedestrians who are not authorized to enter runways. That's actually trending down in fiscal year 22. But it's important to note that this is the #1 event type captured in our system. For everyone listening, we've had 514 total events of this type since fiscal year 2018. Now, for the next 4 events that we're going to be talking about, you need to think and be reminded that we're talking about authorized personnel here accessing the runway. This could be vehicles, personnel, maybe a maintenance taxi. Now, in this case, these are actually authorized personnel that enter the field, crossed a runway without authorization. It's important to note that this is the second highest event type in our data set. And the data currently shows that we are trending higher in this category in fiscal year 22 compared to fiscal year 21, and actually trending to match our fiscal year 19 numbers. Now, going all the way back to fiscal year 18, we've actually had 496 events of this type, and it's trailing very closely behind the #1 type of unauthorized access to the runways. So again, we're talking about authorized personnel here, and we're talking about authorized personnel that cross a hold short line. But in these cases, they didn't make the runway edge. So they crossed and they didn't make the runway edge. Now, our numbers for this type are actually trending lower than previous years. But it's important to note on this slide that this is always a top 5. And it's consistently following in the top 5, so we need to keep it in the back of our minds. Now, for the next 2 data event types, this really should prompt some additional discussion at your local facilities and with everyone involved. And this will actually wrap up our runway incursion trends. Now, both of these events include direct communication, acknowledgement of instructions, and I want to emphasize acknowledgement of instructions, and then some action which actually caused a runway incursion. So unfortunately, both these event types are trending higher in fiscal year 22. In fact, for both of these, we're seeing twice as many events compared to fiscal year 21 in each one of these categories. Now, in this case on the slide, we're talking about an authorized individual who was provided a hold short clearance to the runway, and I need to emphasize with a good readback, and they still entered the runway. This is a significant spike over the previous fiscal years. And again, reminder, we're trending higher than any previous fiscal year in this category. Now, similar to the previous slide, airport vehicles and personnel instructed to hold short, again, with a good readback, cross the hold short line. But in this case, they did not cross the runway edge. This also spiked in fiscal year 22 over the previous year. Now, if we look back across fiscal year 18, the data also indicates that this has been a past issue, and we really should evaluate past mitigations. So that same type event data exists for surface incidents. So primarily when you sort the data, there are two main event types that present themselves, and those are shown on the slide. Again, reemerging, you have those privately owned vehicles and pedestrians who aren't authorized to access the field at all that are doing it anyway. And again, remember, surface incidents, they're accessing the movement area. This does not include accessing the runways. But when it comes to authorized individuals entering, essentially by not following instructions or procedures, we're seeing our event counts in fiscal year 22 exceeding all previous fiscal years. Now, so I was looking at this data and I was wondering, and some of you may be wondering, who in the world is committing these events and what are they doing on the airport? So now this information can actually be derived through our data by looking at some of the narratives that accompany the data we receive. So to provide this list I'm showing on the slide, I completed really just a search within the narratives to see if I could find some commonalities between runway incursions and surface event data. So this list is not broken out by RIs or SIs, and really is in no particular order, but each one of these items listed on the list actually showed up more than one time within the narratives. I felt it was important to share with you today because it could really be a starting place for discussion on surface improvements at your airport. So a quick summary of what I covered in the last few minutes. So we have VPDs, RIs and SIs, the definition we covered earlier. That event data in fiscal year 22 appears to be trending to match or exceed event counts in fiscal year 21. Now, our privately owned vehicles and pedestrians, those that aren't authorized on the airfield, annually contribute to the most RIs and SIs in our data set. We have SIs, they're actually accounting for 34% of all of our events, and we kind of show that these are trending upwards. So RIs and SIs should be addressed when talking about surface safety. And lastly, as I summarize what I just talked about, in fiscal year 22, there has been an increase in communication and situational awareness events for RIs and SIs. Now, I told you when we started, we were going to sort of wrap up with some recommendations. So based on what we presented, Gio and I want to provide some recommendations to prompt ongoing discussion. Now, first, we really want you to think about what sort of tenant outreach you're doing. Now, at towered airports, are your tenants participating in runway safety action team meetings or RSATs? Steve actually mentioned those in his presentation. At towered and non-towered facilities, our surface operators provided surface safety education, classes or procedures, or is this message provided to them through like notices, bulletins, or discussions to ensure all tenants have an understanding operating around the airport? Now, for security or access control, we actually acknowledge that this can really vary depending on your airfield characteristics. And we have a lot of different airports joining us today. We really just want you to think about the last time you changed your gate codes. Now, how is your security and access control compared to your tenants? Do you have an escort policy? And critically, do the vehicles and surface operators not approved to operate on the field need to take specific routes to avoid potential surface incidents or runway incursions? Let me hand it over to Gio to talk about the next recommendation.
So thanks, Tom. So when we look at trending data and what we kind of go back to root cause, I kind of like to try to break it down to its plan, the awareness piece, and the communication piece. And we kind of have a lot of that communication, phraseology, awareness, site specific. When you have a driver that's going to go out on the airfield, that airport operator has badges individual, to me, it's imperative that they understand there's a planning component. The airport may be operating in a north flow, and I'm going to go this way. And then before they go out there, are we still operating in that direction, or has it changed to a south flow? And now different taxiways are being utilized differently, that they can't really, they have to adjust, how are they going to get to their destination utilizing that movement area? Awareness. Do they always know where they are? And this is imperative, because when we look at runway incursions, and you look at Tom, getting the read back correctly, is obviously there's a lack of situational awareness that I am now crossing a hold short line and I'm entering that runway area into the RSA and getting onto that runway edge line. And then the communication piece. And I think we have to acknowledge that with air traffic, we speak a language unto our own. We use that alphabet of Alpha, Delta, Golf, and we're giving taxi instructions and issuing different routes to vehicles. That person must understand what's being said. And I will say this over and over during the next couple of days. If you don't understand, do not go on assumptions. Stop and ask for clarifications. ATC is there to help you. That's their job. They're going to sit there and try to mitigate that runway incursion and make sure that you can get to where you want to be on that airfield safely. So, and these are, to me, I think some of the best practices really, at your local airport. But one thing I also want to share is that relationship between that air traffic control facility and that airport operator really is key to mitigating that risk. So when you do have these events, have those conversations, sit down, review it. How can we do better together? Because really, we're all in this together. So back to you, Tom.
Absolutely, Joe. Great points on the driver's training. And I just want to reemphasize how important communication is at our non-towered facilities also. We do talk a lot about communication with air traffic control, because that communication occurs a lot and it's a two-way communication. But it is also important for those that are operating at non-towered facilities to have clear and concise and situational awareness when it comes to communication, because those operating in the air are really counting on us letting them know from surface operators what's going on down on actually the facility. So I just wanted to point that out. So really that point-to-point understanding between all parties is extremely critical. Now for the next recommendation, we actually are wondering if you're sharing runway incursion and surface incident data when you have it or when events occur at your airport. Now, we didn't have time here today to actually share specific examples of RIs and SIs along with lessons learned, but we have found that sharing these events actually provides heightened increased situational awareness and system improvements across the board. So we really say, share these experiences between each other. Everyone listening today, share them with your surface operators and your tenants. I always tell people, you really don't know what you don't know, and sharing that information helps everyone know. And lastly, really just share and use resources. Share training programs and explore the resources available for industry stakeholders in the FAA. So this includes training supplements to support programs that you're building at your airport. Now, each one of you listening today is a resource. And I did say it a few minutes ago, and actually just echoing what Shanetta and Tim said, your perspective is important in identifying surface safety issues. Now, we know how creative you are within your own programs, and along with industry stakeholders, we can really continue to foster forums, kind of like this symposium, to share and identify additional resources to address surface safety for your surface operators and vehicle drivers. So here's the great news. That actually concludes the presentation on trends. And I really want to thank Gio for his contribution today, and to let the audience know that actually that wraps up our morning presentations before break. Now, we wrapped up a little bit early, but we're going to hold to the same time frame. But before I get to the time frame, I just want to remind everyone participating that you are welcome to ask questions throughout the event using the question and answer section within Zoom. Now, due to the size and number of attendees, we might not get to the questions, but we'll certainly be reviewing those questions for future targeted outreach. So this afternoon, we're diving into construction safety, hot topics, and notice to air emissions, NOTAM modernization. We're really looking forward to those panels. The symposium will resume at 12:50 p.m. Eastern, and we'll be opening the symposium after lunch by showing a winter operations video. We hope you have a great lunch, and we hope you rejoin us in the afternoon, and we'll see you real soon.